Imagine this. You're on a ship, you're sailing towards the horizon, the sun is setting, it dips below the edge, you've reached the end of the world. Sounds crazy? Well, this is what people believed for centuries. Before we knew better, the idea of a flat Earth seemed completely logical. Today we know our planet is a sphere, but some still cling to the flat Earth theory. It's a fascinating example of how our perceptions can be deceiving. It also shows how crucial scientific thinking is. The idea of a flat Earth is ancient. It dates back to the earliest civilizations, where the concept of a flat Earth was a common belief. Many cultures held this belief. Ancient Egyptians, Babylonians, and early Greeks all imagined a flat Earth. These civilizations, with their rich histories and advanced knowledge in various fields, still saw the Earth as a flat plane. They created maps and depictions that reflected this understanding. The flat Earth was not just a myth, but a well-accepted reality for them. Their worldviews were shaped by the limitations of their observational tools and the knowledge available at the time. It was a natural conclusion based on their observations. When they looked out at the horizon, it appeared flat. The vast landscapes and the way the horizon stretched out endlessly reinforced this belief. After all, the Earth looks pretty flat from where we stand, right? This perception was further solidified by the lack of evidence to the contrary. Without advanced technology, their observations were limited to what they could see with the naked eye.
The spherical Earth model gained acceptance around the 5th century BC. This was a significant shift in understanding, driven by the intellectual advancements of the time. Thanks to the ancient Greeks, particularly Pythagoras and Aristotle, who made observations and used logic to deduce our planet's true shape. Their work laid the foundation for modern astronomy and challenged the flat Earth paradigm. They observed the stars, the moon, and the sun, and used these observations to argue for a spherical Earth. Their logical reasoning and scientific methods were revolutionary for their time. But the flat Earth idea didn't disappear entirely. Despite the advancements in scientific understanding, the flat Earth theory persisted in various forms. It had a resurgence in the 19th century and has been kept alive by various groups and individuals ever since. Even today, in the age of space exploration and satellite imagery, there are still those who advocate for a flat Earth, demonstrating the enduring nature of this ancient belief.
So what do flat earthers believe? Their core belief is simple: the Earth is a flat disk. This disk is surrounded by an ice wall, often identified as Antarctica. This wall prevents us from falling off the edge.
Above this disk, the sun and moon are much smaller than scientists claim. They revolve around the Earth like celestial spotlights. Gravity? It's an illusion in the flat Earth model. Objects simply fall down. The stars? Just points of light on a dome above us.
Flat earthers present various arguments to support their beliefs. They often question the validity of images from space. They argue that NASA is part of a grand conspiracy. They claim we haven't actually been to space.
They point to the lack of visible curvature in everyday life. They question how airplanes can land if the Earth is spinning. They even argue that lunar eclipses are caused by a mysterious shadow object.
Section 5. Science Strikes Back. Debunking the myths. In this section, we will tackle some of the most persistent myths and misconceptions that have been circulating for years. These myths often seem plausible at first glance, but with a closer look, we can see how science provides clear and definitive answers. These arguments might seem convincing at first. They often play on our intuitions and the limitations of our everyday experiences. However, when we delve deeper into the scientific evidence, these arguments quickly fall apart. But they crumble under scientific scrutiny. Scientists have spent centuries studying the Earth and the universe, and their findings are based on rigorous testing and peer-reviewed research. Let's start with the lack of visible curvature. Many people argue that because we can't see the Earth's curvature from the ground, it must be flat. Yes, the Earth is enormous. Its vast size means that the curvature is not easily visible to the naked eye from ground level. We can't see its curvature from the ground with the naked eye. This is simply due to the scale of the Earth compared to our field of vision. But we can observe it indirectly. For instance, when we watch ships at sea, they disappear hull first over the horizon. Ships disappear hull first over the horizon. This phenomenon is a clear indication of the Earth's curvature. Airplanes need to constantly adjust their altitude to follow the Earth's curvature. Pilots are trained to make these adjustments to ensure safe and efficient flights. As for satellite imagery and space travel being fake, these claims are easily debunked by the overwhelming amount of evidence we have from multiple sources. Countless independent sources verify their authenticity. Space agencies around the world, such as NASA and ESA, provide a wealth of data and images that confirm the spherical nature of the Earth. We have decades of evidence, including GPS navigation, which relies on satellites orbiting a spherical Earth. GPS technology is used daily by millions of people around the globe, and it wouldn't work if the Earth were flat. The precision and reliability of GPS systems are a testament to the accuracy of our understanding of the Earth's shape. These systems depend on the principles of physics and mathematics that only apply to a spherical Earth. From the early days of space exploration to the present, every mission has provided further proof of the Earth's roundness. The images and data collected by astronauts and satellites leave no room for doubt. Education and awareness are key to debunking these myths. By understanding the science and evidence behind these concepts, we can dispel misinformation and appreciate the true nature of our planet. Let's continue to explore, question, and learn. Science is a journey of discovery, and by embracing it, we can uncover the wonders of our world and beyond. Section 6, DIY Earth Curvature Proofs. You don't need to be a rocket scientist to prove the Earth is round. Simple experiments can demonstrate the Earth's curvature. One classic example involves observing a ship sailing towards the horizon. As the ship approaches, it gradually appears over the horizon, starting with the mast and finally revealing the hull. This wouldn't happen if the Earth were flat. Another experiment involves shadows. By comparing the length of shadows cast by identical objects at different latitudes, we can calculate the Earth's circumference. This method was used by the ancient Greeks over 2,000 years ago. Section 7, Flat Earth in the Digital Age. The internet has acted as a catalyst for the resurgence of the flat Earth theory.
Social media platforms in particular have allowed these ideas to spread rapidly. Online communities dedicated to the flat Earth theory have emerged. They share videos, articles, and memes, often laced with misinformation and conspiracy theories.
The accessibility of information online is a double-edged sword. While it allows us to access a wealth of knowledge, it also makes it easier to spread misinformation and disinformation. This is where critical thinking becomes crucial. Section 8, Conspiracy Theories, a Slippery Slope. Conspiracy theories have always been a part of human history, but in recent times they seem to have gained more traction and visibility, especially with the rise of social media and the internet. The flat Earth belief often goes hand in hand with other conspiracy theories. These theories can range from the moon landing being faked to more recent claims about global pandemics being orchestrated by shadowy elites.
This can lead to a dangerous distrust of science and established knowledge. When people start to believe that scientists and experts are part of a grand conspiracy, it undermines the very foundation of our understanding of the world. When people reject well-established facts, it becomes challenging to address real-world problems. For instance, climate change is a pressing issue that requires collective action, but if a significant portion of the population believes it's a hoax, it hampers efforts to mitigate its effects. It erodes trust in experts and institutions, which are crucial for a functioning society. Trust in these institutions is essential for public health, safety, and the overall well-being of communities.
It's one thing to question and explore different perspectives. Healthy skepticism is a valuable trait that encourages us to seek out the truth and not take everything at face value. It's another to deny overwhelming evidence and embrace unfounded claims. When we ignore the consensus of experts and cling to baseless theories, we risk making poor decisions that can have serious consequences. Critical thinking is about asking questions, yes, but it's also about evaluating evidence, considering different viewpoints, and being open to changing our minds when presented with compelling evidence. It's a balance between curiosity and discernment, ensuring that our quest for knowledge is grounded in reality and not swayed by misinformation.
Section 9, In Science We Trust. The scientific method is our most reliable tool for understanding the universe. It's based on observation, experimentation, and the constant testing of hypotheses. Theories that hold up to scrutiny are accepted, while those that don't are discarded or refined. The spherical Earth model has been confirmed through centuries of scientific inquiry. We have countless observations